Welcome back. We're now going to talk through a problem definition example. The example would be buying a car, something that we're all familiar with or have certainly seen happen, if not yourselves, maybe a family member or a friend. All right, so first step in the problem definition phase is research and stakeholder analysis. So in our stakeholder analysis, we're going to assume we talk to some key members of a family that are interested in buying a car. And we came up with this list on the left of findings. All right, so we found that how far they commute in a given day, the impact of a breakdown, the importance of safety, and some of the activities, right? So if they have a child on the soccer team, for an example. All right, from there, we're able to draw some conclusions, put some of these findings together, and identify some key trends that are going on. So the importance of efficiency for the vehicle, the importance of safety, and we might need to transport a whole soccer team, right? So another important consideration. And then from there, we make a final recommendation, all right? And our recommendation would be something along the lines of the vehicle should be able to safely transport as many passengers as possible while being both dependable and fuel efficient. Important note when we're talking about an FCR matrix is that we had 4 findings, 3 conclusions, 1 recommendation. Ideally, we see something like this where we don't have 4 findings and 4 conclusions and 4 recommendations. We want to do some synthesis, put ideas together, and kind of develop our conclusions and our recommendations in a coherent way. All right, so this would be an FCR matrix if we were buying a car. Our next step in the SDP in the problem definition phase is functional analysis. So in the functional analysis, we establish first our fundamental objective and then our supporting functions. So if we're talking about buying a car, our fundamental objective would be, as stated in the green box here, we'd want to procure a long-lasting vehicle that can safely and efficiently transport people from one location to another across all types of terrain and weather. All right, so if that's our fundamental objective, our key function that we need to accomplish for there to be system success, our supporting functions are then listed in blue and nested underneath. All right, so first we need to make sure we're providing safety. Secondly, we want to enhance efficiency. Third, we want to be able to carry passengers. And fourth, we want to ensure overall dependability. Now, the key thing to note here, and we'll talk about this more, but our functional analysis, our functions listed in blue are all in the order verb object. So we always build our functional statements to be a verb object format. It makes it very straightforward to understand, and that is the standard in the systems engineering realm. So this would be an example of a functional analysis hierarchy for buying a car. All right, from there we move forward into our value modeling. So we take essentially our functional hierarchy and continue to build from there. All right, so we have our same fundamental objective and our same 4 functions, but now we have to build out our objectives and our value measures. So our objectives are our 3rd tier, and we always use a maximize, minimize, or sometimes we'll say optimize, but one of those 3 words. And then beneath that, we have what we call our value measures. Okay, so our objectives are for providing safety. We can measure that. How can we measure that? It's by maximizing the safety rating. That would be our objective there. And then our value measure, our way of quantifying safety rating would be, we could say crash test rating, right? And number of stars, more stars is better. When we're looking at enhancing efficiency, we can have 3 objectives for this one. And our first one is maximize dependability. And again, we could look at the dependability rating in stars from a Consumer Reports or an Edmunds as a source. And more stars are better for dependability. We can maximize fuel economy. And we can look at that very directly by looking at the highway gas mileage. And then we can look to maximize warranty, and that it could just be simply the manufacturer's warranty in total miles driven. All right, moving on to carry passengers. Our objective is fairly straightforward here. It's the we want to maximize the number of passengers legally allowed to be transported by the vehicle. And then that's just simply number of passengers. How many people, how many seatbelts do we have? And then our final function, our objective could be for dependability. We could maximize the consumer reports rating, so the overall consumer reports rating. And then we would look at that by just simply using the consumer reports rating. All right, so this would be our qualitative value model. And then from here, we would need to go into assigning weights to our 6 value measures, and these being our value measures across the bottom. All right, so we use this tool called the swing weight matrix, which we will talk about more in a future class. But essentially, we score our value measures from 1 to 100, with 100 being the most important and the most variation. Then we could go all the way down to 1 if we needed to. In this example, we go from 100 for highway gas mileage, and then you can see we go all the way down. The lowest swing weight we give is a swing weight of 40, which we give to consumer reports. Okay, and we have other swing weights assigned to each of our value measures. One value measure receives 1 swing weight, and then we'll use this equation over on the right to determine our actual weights. So we'll take an individual weight and divide it by the sum of all weights, and that will give us our W sub I using that equation 10.2 from the text. And then once we have our swing weights and our qualitative value model, we'll then build our quantitative value model, which again, we had 6 value measures. We should have 6 what we call value functions. So here we have value functions, 1 per value measure. And essentially what we're doing is we're scoring, establishing scores for each value measure from 0 to 100. Okay, so if we look at crash test rating, on our x-axis, we have the number of stars that are acceptable. So if we got a 2-star rating, that is the minimal acceptable. So a 2-star rating receives a value score of 0. 5-star rating receives all the way up to 100. And you can see our y-axis for all of our different value measures is value, right? What we're trying to do with these value functions is convert different metrics, different ways of measuring our value measures, translate them all into the value currency, if you will. All right, and also important to note is that in some examples, in some instances, we have discrete, so we use a bar graph. For example, crash test ratings, you can only get a 2, a 3, a 4, or a 5. But something like miles per gallon, we use a continuous function, since a vehicle can have any miles per gallon, even between 25 and 30. You could have 27.5 miles per gallon would be acceptable. All right, that is essentially what we would do for the problem definition phase of buying a car. And then at this point, we would go forward into the solution design phase, where we would start thinking about different alternatives, what cars we might want to consider. So this concludes our problem definition example of buying a car, and then our next video will be specifically on stakeholder analysis.